Welcome everyone to the class exercise for class 5 in the Cloud Solutions and API Integrations Omaha Data Science Academy class. I'm the instructor, Jeremy Bergman, and in this exercise we're going to use Synapse Analytics pipelines to connect data from REST API, specifically a cryptocurrency REST API, over to the MySQL tables that we created in lecture 4 in the exercise there. So in exercise 4, we took files out of the data lake and we used the copy utility in Azure Data Factory to be able to copy the data from the CSV in the data lake over to the MySQL table. So now we will fully automate this process by connecting directly to the overall crypto history on the REST API and automating that data feed via Synapse Analytics pipelines. So we will go ahead and do that in this example, and we'll actually set up and launch Synapse Analytics within the ODSA resource group. So we will go to portal.azure.com. You could get there a number of ways. Usually if you've used it before, it'll be one of your favorites, where you could go into the resource group itself and do that. You should have already set this up. We did that as part of homework 1. If you haven't, go ahead and revisit homework 1 to do that. We'll open Synapse Analytics. That will take us to our integrated development environment or workspace. And then, as with all data pipelines, we will first create the link services for the pipelines. The link services to be able to connect it from whatever service, whether it's a managed service or your own on-prem service, connecting that to the pipeline for the input data set, and then doing that also for the output data set. So then we will create a link service here to the Azure MySQL database, like we did in exercise 4 in the fourth exercise in the fourth lecture. We'll do it in the same way and create a data set, and then finally connect it all together. So very similar process to Data Factory. We're now just doing it for analytical purposes within Synapse Analytics. And Synapse Analytics being that all-encompassing analytical platform to ingest, explore, and analyze, visualize data. That shared, highly integrated platform for data engineering and data science and other data purposes. So first, what we want to do is go to data. We want to create our linked data sets. So I've created one already for ODSA data lake. That's one data lake that I have already created back in homework 2. I just continue to use that one because that's where the crypto CSV files are at. Actually, we are not connecting to the storage. We want to connect to the REST API service. So wrong is starting to tell you that we actually want to create the REST API service this time. But if we were to connect to the data lake, that is the way that we could do it within the service also. So first, we will create an integration, and this one we connect to external data. We can do an integration data set. Here we'll do an integrations data set. Synapse Analytics allows you to do all in one. So if we go to type in REST, give it a name, ODSA REST API Coin Hist JB. We could create a new link service within this. So we're setting up the data set and the link service at the same time. What did I call this? I called this one ODSA REST API Connector Crypto Overall History JB. So giving it a descriptive name on what that link service is. We need our base URL to be the API LiveCoinWatch overview history. Let's go ahead and copy this image as we work so that we can more easily enter the details. I'll put this in Paint. Oops. Or I could even do something like this. There we go. That works out nicely. So the base URL is https API LiveCoinWatch.com overview history. If you have not got your API key, you will need to do that from this website, LiveCoinWatch.com. I think it's it's not an API. You can go to API. You can try it out. I've already got my API key. I'll give you your API key once you sign up and try it out. Sign up for an account and try it out. And you could use your API key with the service. So authentication type, we want to do this as anonymous because we'll put the information that we need in the headers. So we'll go back to this link service we're setting up. And then our auth headers, we have two of them. So the X API key is where you'll put your API key that you got out of the from the service. It'll look like this. And then your content type. So content type is really like a parameter to tell the service what type of data you're sending in the body of the REST API call. So with this one, we want application JSON. We're going to send JSON data in the application body. You can test to see if it works. Connection is successful. I've already created mine, so I won't save it. So it works just slightly differently than Azure Data Factory. As you see, you created the link service and integration data set all in one, but you still have to create both of those to use it in the pipeline. So now we have our input data set. Now we need our target data set. So you can do the same by creating a connection to the MySQL database that we're using in class. I've done that already, but I'll show you how to do that. Create an integration data set, Azure database for MySQL. Call mine ODSAMySQL, and you can put your initials there. I've already created a link service, but you can hit new. And then this link service, see what we called it here. ODSAMySQL, did we call that the same thing? Sure. You can give it the same name, and that seems to work okay. You just can't have duplicate names across like link services or data sets, but since one's a link service and one's a data set, it seems to work. Enter the database information manually. So we can do this. ODSA MySQL database.azure.com. Database name, J. Bergman. That'll be your schema name that you're given, and then your username and the password that you were given in class. So if you wanted to test that out, you could do test connection. Always a decent idea. I've already created all this, so I won't do that. And now once you have those two, you can create this pipeline. So what we'll do is go to integrate, new pipeline. We'll do that activity like we did in Data Factory, copy data, make sure the mapping's correct, publish all the changes, and check it like we did in the last exercise. We'll go to over here to integrate pipelines, called it Crypto API History JB, where we put the copy data utility into it. All right. So you could do Synapse or move and transform, copy data. I've already given this pipeline a name, saved it. Actually going to close a couple of these just so we can focus on this one. Yep, and then I gave the copy activity a name after I copied it in. So now source, we can use that source data set that we created. Now notice we do something here, a couple things. So since we're using REST API, we have to tell it what type of method we do. This is a post method because in the body, we're going to send this JSON. And that's why we also did that header and told it to do JSON. So we say we want the market cap in USD, and these are the start and end dates we want data for. So just to make sure it works, go ahead and preview data. You can see there's the response. So sync data set, this is our database table. The table fact overview history, the tables that we created using that SQL script. Get the schema and everything. Now that you have those set up, you can do the mapping to import schemas. This will be important because likely you'll have to map those JSON elements over to the table. Awesome thing is that Synapse Analytics parses the JSON response itself and then tries to do the best job it can to matching it to a column. So we'll go ahead. It didn't have date to date number exactly, but we'll go ahead and set that. Looks like it's going to map pretty well. We'll publish all. And while we do so, I'll show you how this works. We'll go ahead and get Data Studio out. And just to show you for illustration purposes, let's truncate that table and clear out all the results. So if we do select star from there in our schema, we don't have anything in there. That's what the truncate keyword does in SQL. So once that data set is published, let's go ahead and trigger this pipeline that takes that API data and syncs it with the table. Okay, so this is running in the background. You can tell that from notifications. It'll give you a little notify once it's complete. Nope, it's successfully completed. Awesome. So make sure that the results are what you expect and it didn't just complete the complete. Now, interestingly enough, I selected that table and I didn't get any results back. So not quite what I was expecting. Recording something. You're leave me alone for a second. So let's go ahead and see what happened with this table. Perhaps it didn't go where I expected it to, so let's go ahead and go back. It's a good opportunity to be able to see what happened here. Table overview, fact history. Oops, so I actually copied this over to a different database. That is why. So if we go to CryptoOverallHistJB, I'll give everybody access to the schema shortly to be able to do the final project. So there are those 4 records we got from that REST API. Actually, it did it twice. It's 2 records, and it appended the same records in here. But looks like it works. We could prove it to ourselves that that process worked. If we just do that, we run it. That should clear out all the results. Okay, that did it. And now if we run that pipeline one more time, now that we know where those results are going, we can trigger this process now. This should, in a second, say it ran successfully. I think it did last time. It just didn't go to the table I expected it to from how I set up the link server. Still running. Okay, completed successfully. So now we can go to this schema to overview history and run this, and now we should have results. Yep, there we go. There are the 2 results from the API call loading it into the table. So that is how this exercise works. Now we have really like an automated data flow instead of having to do it by filling data into an Excel sheet or CSV files or whatever. We can just programmatically go out to the API, give it the credentials that we need, set up these integration data sets and pipeline, and then trigger the pipeline and feed the table its results. So really a way to automate the workflows. All right. So that's it for this exercise in class 5. If you have questions as you do your final project, this will be part of it, as far as taking this REST API and then creating 2 more tables and then filling those in, and then creating a predictive model. So this will be part of it, automating it using REST API. If you have questions, please let me know. All right. Thanks, class.